Graphing inequalities, everybody's favorite. But what I've done is I've given you some steps for graphing inequalities that are foolproof. If you use these steps, you'll be able to graph your inequality really well, or your system of inequalities really well every time. So, the first thing you're going to do when you graph an inequality is graph the boundary line. And what the boundary line is, and it's kind of hard to read this in here, but it's the line you get if you replaced your inequality sign with an equal sign. So y, your inequality is y is less than or equal to x plus 1. So your boundary line is this. So we're going to graph this line. Now we're going to graph it as a solid line because we know our boundary line is included in our solution because this is less than or equal to. If this were just less than, it would be a dotted line. So, I'm going to graph a solid line here. Now, if you remember from last week, the most efficient way to graph a line that's in slope-intercept form, the slope is 1 and the y-intercept is 1, the most efficient way is to graph the y-intercept and then use the slope to find a second point. So, my y-intercept is at 1, and then I can go up 1, over 1 for my slope, because this is the same as 1 over 1, rise over run of 1 over 1. I'm going to just make a sketch. Of course, you'll draw it neater at home with your ruler. So that's my boundary line. Now, to determine, basically this line divides the plane into half planes. I've got the half plane that's below it and the half plane that's above it, and it goes on forever. So we have to decide which half plane we need to color in. All right? To do that, you're going to pick a point. So here where it says pick a blank, it's a test point. If the line doesn't go through 0, 0, I like to use 0, 0 as my test point because it's really easy. And this line does not go through 0, 0. So let's use 0, 0 as our test point. We're going to put that into our original inequality. 0 is less than or equal to 0 plus 1. Oh, look, we got a true statement. If this is true, I'm going to shade on the same side where my test point was. If this hadn't produced a true statement, I'd shade on the other side. And that's how you decide how to shade. So now I know, and I'm going to do this in a color. I'm going to use orange. I'm going to shade on this side. Okay?
So you're shading on that side
because the test point that I plugged in is on this side, and it made this a true statement. Okay? If I had gotten 0 is greater than 1, I would have shaded over here where the test point isn't. All right? Now, we're going to do the second one, and then I'm going to show you what I would do to combine them. In fact, we're going to do this. I'm going to do it on the same graph. And that way you'll see, if I had been given the task of graphing these two as a system of equations, how I would do it. And that's what's in the PowerPoint that's on my website. Okay, so the next one we're graphing is 3x minus 2y is greater than 6. So we have 3x minus 2y is greater than 6. It's going to be a dotted line. First thing we're going to do is we're going to set up our boundary line by making this an equal sign. Okay? So I need to graph my boundary line, and I need to make it dotted because of that. Now, if you'll remember, when this is in standard form, we did this last week, the most efficient way to graph is to use your x and y intercept. That's your 2 points. You can get your y-intercept by setting x equal to 0. What's my y-intercept?
-3.
-3. So my y-intercept is -3. I can get my x-intercept by setting y equal to 0. What's my x-intercept?
2.
So x-intercept is 2. So my y-intercept, if I do this, 1, 2, 3, is -3. My x-intercept is 2. And I have to have a dotted line. So I'm going to draw a dotted line. I'm using the same graph because I want to show you what would happen when I combine these. Okay, so I have my dotted line. Now, first I need to figure out which side to shade. Okay, so I'm going to pick a test point. Now notice, 0, 0 is not on my line. So I'm going to pick this test point. If this is true, if it works for that inequality, I'll shade on the side with 0, 0. If it's not true, I'll shade on the side that doesn't have 0, 0. Okay, let me fix my orange lines just so they're very clear that they're from that solid line. Okay. Now, what happens when we plug 0, 0 in here? We get 0 minus 0, which is 0, is greater than 6. That's not true. So that means I have to shade, here's my dotted line, on this side, because this side doesn't contain 0, 0. So, if I shade on this side from my dotted line, remember it's from the dotted line, okay? Then, my solution, if I had been asked to solve a system of equations, with the first one being that y is less than or equal to x plus 1, that was the other one we had. If I were solving that system, my solution would be where the blue and the orange overlap. So it would be all of this and all of this. It would exclude the area that's only blue, and it would exclude the area that's only orange. It would include just the overlapping area. And that's what's in that PowerPoint on graphing inequalities, systems of inequalities. Oh, I keep looking at the clock.
It's 9:40.
It's 9:40. Oh, we did it. That was everything. So, on the bottom, it says, be sure to review the 2 Task 6 handouts. Really important. I'd have them out when you're doing your homework. And watch both the PowerPoints that are in Task 6. Okay?